All right, now that we have practiced our steps or learned our steps for solving two-step equations, let's practice them. Okay, so just to solve each equation algebraically. Okay, and it is really important. I know it's going to be hard to do your homework, but it's really important that I see your work to the best of your ability. Okay, because if you're messing something up like subtracting or you're supposed to be adding or something like that, I can correct that mistake and save you a lot of headaches down the line. So really try to show me all your work. Okay, solve each equation algebraically. Now this step here, you don't have to do, but if you don't do it, you need to recognize we're talking about two sides of the equal sign, okay? So remember, step one was to simplify each side. If I look at the left here, that's 5x plus 4, nothing to simplify. Can't add them together, not like terms. Just a 19 over here, nothing to simplify. So now we solve for our variable term. My variable is x. It's the only thing I don't know what it is. And so I'm going to solve for 5x. Excuse me. So I'm going to get rid of whatever, is being added on to it or subtracted from it. Again, order of operations backwards. Since the 4 is being added on, I'm going to do the opposite, or what's called the inverse, and to get rid of it. So if it's positive 4 there, or plus 4, I'm going to subtract 4. Okay, and we're going to think of it right now as plus 4 minus 4, but we're going to transition our thinking to positives and negatives. So sometimes you'll hear me refer to that because that's where we're going to get to. Whatever I do to one side of the equal sign, got to do to the other. Okay, make sure you are clear that that's a 4. All right, so now I'm just going to bring down my 5x. Okay, those just random marks I made there. Plus 4, minus 4. Think of it. Think of it when we were learning integers, right? When you add opposites, they add to 0. It's kind of why we did that. So I bring down my equal sign. 19 minus 4, 19 plus a negative 4 is 15. Okay, that's step 2. Now step 3 says we use multiplication and division to solve for our variable. Since this is 5 times x, I'm going to do the inverse, or the opposite of multiplying. I'm going to divide. What am I going to divide by? Whatever the coefficient of x is, because 5 divided by 5 is 1. That gives me 1x. Whatever I do to one side, got to do to the other. Okay, remember, equations keep something in balance, right? Think of the scale. You can't like divide one side by 5 and not the other side, because then they won't be in balance. So, oops, lost my line. 15 divided by 5 is 3. Now here's the really cool thing about equations. Without ever turning it in, you can know if you're right or not. Okay, here's how. We just said that x equals 5. I'm sorry, no we didn't. We said that x equals 3. So let's see if we're right. This says 5 times whatever x is plus 4 equals 19. Well, is 5 times 3 plus 4, does that equal 19? Well, 5 times 3 is 15. Is 15 plus 4 equal to 19? Okay, cool thing about equations. All you gotta do is plug it back in and you're like, yes, I got it, or oop, no, I don't. Okay, let's look at this example. 2x minus 1 equals 31. Again, I'm gonna throw my wall in here, right? So I can see each side. Can I simplify either side? Nope, not like terms. Nope, just a single number. So now I'm going to identify my variable. It's x. So my variable term is 2x. So starting from order operations, bottom to top, start with adding and subtracting. Now in this case, we're subtracting 1. So the opposite or the inverse of subtracting is adding 1. Whatever I do to one side, do to the other. Bring down my 2x. Minus 1 plus 1, I think of the number line. If you go down 1 and back 1, you're at 0. Go on. Equals 31 plus 1 is 32. Step 3, using multiplication and division. This is 2 times x, so I'm going to do the inverse. I'm going to divide. I'm going to divide by 2 because 2 divided by 2 is 1. 1x. Whatever I do to one side, do to the other. 32 divided by 2 is 16. Bring down my equal sign. Want to double check it? I said x equals 16. Well, does 2 times 16 minus 1, does that equal 31? Well, 2 times 16 is 32, and 32 minus 1 is 31, so it checks. Do you guys get the idea that we're just going to keep doing the same thing over and over, and I'm going to keep asking the same questions over and over? Because that's really what's going to happen, okay? even for word problems. Claire's mom found a very good price on a large computer monitor. She paid $325 for a monitor. So this is what she paid. This is what it equals, right? It was only $65 more than, well, more than is plus, half the original price. What was the original price? Well, I'm going to start out, since we're looking for the original price, I'm going to say let x, why x? I don't know, it's a variable we use a lot in algebra. You can use whatever you want. Let x be the original price. Okay? X is the original price. So if I have half the original price, that's half times x. Okay? Half of something, that's when we're multiplying. And 65 more than that, so I'm going to go plus 65. And that's going to equal 325. All right. So guess what we're going to do here? We're going to solve. Okay. All right. So whatever's being added on here is 65. Now, you know what? Nope, we're just going to keep going with it. Sorry, I had a thought. We're going to push it off to later. Okay. I am solving for my variable term, half of x right here. So whatever's being added on, even if the 65 came out front here, and that's what I wanted to show you, just find whatever's being added onto this, do the inverse to subtract it. Okay. So I'm going to subtract 65. Whatever I do to one side, do to the other. I bring down my half of x. That gives me 0 equals, and I believe that works out to be 260. Okay. I'm going to bring this up here because we need to talk about how we deal with this half. Okay? This is half times x. So we undo multiplying by dividing. Okay? 1/2 divided by 1/2 is 1x. Awesome. Except, okay, if we think of dividing by a half here, remember dividing by fractions? 260 divided by a half. Keep it, switch it, flip it, okay? So dividing by a half is really the same thing as multiplying by 2. Okay, and I'll do another example down here that shows you that. Dividing is the same thing as multiplying by the reciprocal. Keep it, switch it, flip it, okay? So 260 times 2 ends up being, looking at my cheat sheet here where I did the calculations, $520. So does that make sense? Well, she paid $325 for a monitor that was 65 more than half the original price. Well, half the original price is a lot. She pays $325. Okay, kind of makes sense that $520 would be the original price because she's paying less. Okay, a couple more examples and we're done. And you're gonna hear me say the same things over and over. Okay, first of all, we need to look at our equation, find my equal sign, and simplify each side. So nothing to simplify here, but here again we need that distributive property. So I'm going to go 2 times x, plus sign there, so I'm going to write a plus sign here, 2 times 4. 2 times 4 is 8, equals 18. Do you guys see how just that one simplifying step, this is a two-step equation that we know how to solve. Find your variable term, 2x, get rid of whatever's being added on to or subtracted from it. Well, this 8, it's plus 8, so I'm going to subtract 8. Whatever I do to one side, you got to do the other. Bring down my 2x. This right here adds a 0. 18 minus 8 or plus a negative 8 is 10. Now one step equation, step 3 of our steps. This is 2 times x, so I undo multiplying with dividing. I divide by 2 because 2 divided by 2 is 1x. Whatever I do to one side, I do to the other. 10 divided by 2 is 5. Okay, and you absolutely could plug that in, see if it's an answer. If I put 5 in here, 5 plus 4 is 9. 2 times 9 is 18. Okay, one more of the same thing, but we have a fraction here, so let's spend a little bit of time talking about that. Simplify each side. Done. Done. Find your variable term. So get rid of whatever's being added onto it or subtracted from it. Okay, that's minus 8, so I'm going to add 8. Whatever I do to one side, I do to the other. I have 3/4 times x. That gives me 0. equals 4 plus 8, which is 12. Now, this right here is what I was talking about up here a little bit. We could divide each side by 3/4. Okay, don't write this down. Okay, we could divide each side by 3/4. But remember, and however you want to write it is fine. Okay, remember though, what I want you to remember is dividing is the same thing as multiplying by the reciprocal. Dividing is the same thing as multiplying by the reciprocal. So notice these 3's cancel, these 4's cancel into a whole bunch of 1's, and we have 1x equals. We could also multiply this by 4/3. Now, you guys, you can write this as 12 divided by 3/4, and then go 12 divided by 3/4, and then go keep it, switch it, flip it, and notice we're going to get right here. So you can do that, okay? There's nothing wrong with that, okay? I'm just trying to show you that instead of thinking of it as dividing by 3/4, we could do the same thing by multiplying by 4/3. Then I could cross reduce. 4 and 1 have a common factor of 1, doesn't help me out, but 12 and 3 have a common factor of 3. 3 goes into itself 1 time, 3 goes into 12 4 times, and 4 times 4 is 16, okay? So, two-step equations, you guys, you're gonna, as you've noticed how many times I've said these things already in just these notes, you're gonna hear it a lot because we're gonna follow those steps over and over, and it's really gonna become habit for you.